right, so today we are starting chapter 11, which is distance and angles. So we're going to get into a little bit more of the geometric part of the pre-algebra book. Today specifically we are looking at angle and line relationships. Fair warning, this is your favorite day of the lesson. It is a lot of vocab today, so you will be taking a lot of vocab notes, but it is important that we understand these relationships before we move on to the rest of the sections in this chapter. So, talking about angles, we know that angles are formed by two line segments coming together and their vertex in the middle. We're going to look at different types of angles today. The first type of angle that we're looking at is called the vertical angle. They are pairs of opposite angles formed when two lines intersect. So we have the two lines coming across and intersecting each other at the vertex point in the middle. The vertical angles either stack up on top of each other, so angle 1 and angle 2, or they form the right and left pair, so angle 4 and angle 3. Adjacent angles are again a pair of angles, so we have two angles that have the same vertex, so they share that common point, and they also have a common side, so there is one side that both of them share. Notice that the angles do not overlap with each other. We have one angle and the other, and the only place that they touch is on that common side in the middle. So these are two different ways that we can relate pairs of angles. If we have vertical angles, another thing to note about those is that they are congruent. So if one was 120 degrees, then 2 would also be 120 degrees. We have some specific types of adjacent angles that also have measurements that we can use. Complementary angles are a pair of angles that add up to 90 degrees. Remember, the word sum stands for addition. One of the easiest ways to remember complementary angles is they form a corner. So the complementary angles form a corner. The pair of them have to add up to 90 degrees. Supplementary angles, another type of adjacent angles, if you add up those two angles, they form 180 degrees or a straight angle. So those two angles come together to form 180 degrees. Like I said, an easy way to remember the complementary is corner. Both of them start with C. An easy way to remember supplementary is straight. Both of those start with S, supplementary and straight. So that helps you keep it straight between complementary and supplementary. So part of your homework tonight is going to be classifying angle relationships. So they're going to give you pictures like this one here, and they are going to ask you how the angles are related, and then to find the missing angle measurement. So they tell us that we need to classify the relationship and then find the measure of x if the measure of y is 135 degrees. So we can put 135 degrees in the place of y. So looking at these two angles, what pair do they form? If I slide them together, we get that straight line at the top of the square. So those two add up to 180 degrees and they form supplementary angles. Since we know supplementary angles add up to 180 degrees, to find y, we have 180 equals y plus 135. The next step to solve would be subtracting 135 from both sides, leaving us with y being a 45-degree angle. Moving on to the other type of relationship we are looking at today are linear relationships. The first one, you've probably heard of it before, is perpendicular. That is when two lines intersect and form a right angle. Right angle being 90 degrees. So they come together, are two lines, and they form a right angle, forming that corner. A little piece of notation that we have not seen before right here. We use an upside down capital T to represent perpendicular lines. So this symbol in between the L and the M is saying that line L, which is the blue one, and line M, the red one, are perpendicular to each other. Other type of lines that you have probably heard about before, parallel. Those are the two lines that go on forever and never intersect. So if we look down at that image down here, the two that are parallel are S and T. Those two are going on forever. Another notational thing, these arrows on those lines are meant to indicate that they are running parallel. The other notation you might see for that is right there, that there are two vertical lines in between the line names. So S is parallel to line T. So another type of line that we are looking at is the transversal. That is one that cuts between two or more lines on the plane. So we have line R cutting through both S and T. So it is running through two other lines. When a transversal intersects two parallel lines, so the situation we just had back here, S and T are parallel, R is cutting in between them. You have 8 angles that are formed. Those angles are going to have some special relationships. So if your transversal cuts across parallel lines, 8 angles are formed with some specific relationships. First, we are looking at the interior angle. Interior should remind you of inside. That's the key word for where those angles are at. So the interior angles, if we look at these lines, which ones are inside? It's angles 3, 4, 5, and 6. Notice this sign in front of the numbers, it kind of looks like a greater than sign. It actually stands for an angle. So we're looking at 3, 4, 5, and 6 being on the interior. Opposite of that, exterior or outside the parallel lines, we have other angles formed. So in that case, it's going to be 1, 2, 7, and 8. So those are the ones that lie outside the parallel lines. So the transversal L that cut through our 2 parallel lines created 8 angles. 3, 4, 5, and 6 are interior. 1, 2, 8, and 7 are exterior. Specifically looking at the interior angles, there is a special relationship going on called alternate interior angles. So we're looking just at the interior angles, and we are looking for the ones that lie on the opposite side of the transversal. So if I pick out number 3, we are looking for the opposite side of the transversal. There's 2 options on the opposite side, 4 and 5. If we want the alternate interior angle, we are looking for the one that is not touching 3. So the alternate interior angle to 3 is 5. Those 2 angles are congruent. So the first pair is 3 and 5, leaving the second pair to be 4 and 6. Just like we have alternate interior angles, we can also have alternate exterior angles. So these ones are opposite sides of the transversal, but they are outside the parallel lines. So if I pick out 1 as my first angle, you are looking for the opposite exterior angle. Which one do we get? One pairs up, we're going opposite, and then exterior, so we are going down to 7. We want the ones that are across from each other on the outside. So 1 pairs up with 7, which means our other pair of alternate exterior angles is 2 and 8. Corresponding angles. Those are the same position on the parallel lines in relation to the transversal. So our transversal is through the middle of the parallel lines, and we are looking at the 2 separate groups of angles. So we have 1 set on angle J and 1 set on angle K. To find corresponding angles, if I pick 1 to start, so angle 1 is on line J, I'm looking for the matching piece on line K. Angle 1 being in the top left corner means angle 5 matches up as the corresponding piece for line K. There are 3 other sets of corresponding angles. See if you can find them. We have 2 and 6. 3 and 7. And finally we have 4 and 8. So each of the 4 angles has a corresponding angle for the other parallel line. All right, so finally getting to use some of this vocab for the math part. They're going to give you a figure like the one drawn here. It tells you in the figure that A and B are parallel. So you're going to want to look for A and B. Notice those 2 are parallel. Then it tells you that Q and R are your transversal lines. The first question it asks is to classify the relationship between angle 11 and angle 15. So angle 11 and angle 15. We are looking at our two parallel lines, A and B, and our transversal in this case is R. First thing to check is, are they alternate interior? Both angles are not on the inside, so they cannot be interior. Then we check for alternate exterior. 11 is an interior angle, so it cannot be alternate in exterior. That leaves us with corresponding, so we want to check. 11 is in the bottom right position. 15 is also in the bottom right position. So we would say angle 11 and angle 15 are corresponding angles. Yes, you need to write it out in complete sentences. We're not that lazy. Then it gives us, if angle 15 is 78.5 degrees, how big is angle 11 and angle 9? So we're adding another angle, angle 9, into play here. Using what we wrote down in the vocab about corresponding angles, we know that those are congruent, meaning that the measure of angle 11 is also equal to 78.5 degrees. Now we have to mentally check how angle 9 is related to angle 11. This goes way back to the beginning of the lesson, and those two are related by vertical angles. They stack up across from each other. So vertical angles for 9 and 11. The other thing that you could have used is the idea of alternate exterior angles. If you're looking at angle 9 and angle 15, both of those are exterior to our parallel lines A and B, and they're opposite sides on the outside. We also said that those are congruent. So the measure of angle 15 is 78.5 degrees, which means that the measure of angle 9 is also equal to 78.5 degrees. This time we do not have a transversal, so we have angle ABC and angle CBD, and those are related in what way? Those two are going to be adjacent angles. They are touching but not overlapping. It's not one of our special cases. It doesn't tell us that it adds up to 180. It doesn't tell us that it adds up to 90. It actually tells us that the whole angle, ABD, adds up to 164. So that whole angle measurement on the inside is 164 degrees. So we know that those two need to add up to 164. That's where our algebra comes back into play. So we take the measurement of the first angle, which is 2x plus 23, and we add on x for a total of 164 degrees. Adding up our x's, we get 3x plus 23 is 164 degrees. Using SAD MEP, the next thing we do is subtract 23 degrees from both sides, leaving us with 3x equals 141 degrees. Our next step is going to be dividing by 3 so that x is by itself. And when I divide by 3, I end up with x is equal to 47 degrees. At this point, am I done with the problem? No, if I go back and read the question, it asks me for ABC and CBD. I've only found CBD. I've only found one of my angles. To go back and find the other angle, I need to plug x in, so I have 2 times 47 plus 23. 2 times 47 is going to add up to 94 plus 23, giving us a grand total of 117 degrees. Make sure that you label saying ABC is equal to 117 degrees and CBD is equal to 47 degrees so that you distinguish which angle is which. They will not always give you a picture, so in this case all we have is the word problem, which I know is everyone's favorite. So we have angle RST and angle UVW being vertical angles. The measure of RST is 3x and the measure of UVW is 5x minus 36. It asks us to do 2 things. First, find the value of x, then find the value of UVW. What do we know about vertical angles? Vertical angles are congruent or equal to each other. So that means I can say that 3x is equal to 5x minus 36. In order to solve, we need to get our variables by itself. I take 5x away from both sides, and I get negative 2x is equal to negative 36. Remember, we do not lose the negative in front of the 36 just because we took away the 5x. That negative is still there. Last thing I do, divide by a negative 2, and I get x is equal to 18. Again, have I solved the problem? I solved half of it. It asked me to find the value of x. Now I need to go back and solve for UVW. So I need to go back and plug into my original equation, which was 5x minus 36. Plugging in the value of 18, I get 5 times 18 minus 36. 5 times 18 is 90. Subtracting 36 gives me a final answer of 54 degrees. So angle UVW is 54 degrees. Once you have finished taking your notes, go ahead and come up to my desk. I will look over them and give you the homework assignment for the night.